So correlation is something that you may be familiar with probably since high school. If you have two numerical variables that you want to look at the correlation between, so you could plot them as long as they have at least an ordinal level of information. Okay, and typically you use the good old scatter diagram for this one, wherein you have the R squared or the correlation coefficient. So you're probably familiar that these could be done with just a few clicks in programs such as Excel. Okay, and you can correlate a lot of things. Okay, so for example, you may want to look at the association between hedonic results and perhaps probably the sugar level as measured through a certain physicochemical test, or maybe you would want to associate the hedonic results with the demographic results. For example, is there a correlation between the mean hedonic rating and, for example, the age of the panelists? For example, is this drink more liked by younger individuals or the older individuals? Something like that. So ordinal data uses the Spearman's rho coefficient, while interval and ratio or parametric data can use the Pearson's product moment coefficient, or simply known as the R. So the coefficients, again as mentioned, are between -1 to 1. The weakest level of correlation is 0, which looks like randomly scattered points without any trend. And again, an increasing positive correlation means there's a direct relationship. An increase in one involves an increase in the other, while on the other hand, a negative correlation that's getting much closer to -1 involves an inverse correlation, where an increase in one involves a decrease in another. Okay, this type of correlation, however, is limited to linear relationships. So any other relationships, such as those that have peaks or parabolic shapes, cannot be sufficiently determined using a linear correlation. Okay, and there must be enough data to correlate, especially in terms of the range. So if the data are too close to each other, for example, if you're looking at hedonic ratings and they all answered 7s and 8s, that wouldn't be enough to correlate, even if you had, say, 100 respondents. Okay, because no one answered uh, 1 to 6 or 9, so that's not enough information. And then of course we do assume that the readings are independent of each other. So by the way, kung gusto pala nating ipilit na gumamit ng mga linear regression analysis, it's possible to do data transformation such that curvilinear, or those with higher orders of relationships, can be translated into linear. However, of course, that's also where data modeling enters into the fray now, but we'll discuss that later. So again, for association or correlation rather between variables, one thing that you could use is the Spearman's rho coefficient with the equation and explanation here. So again, it's a summation of the differences between the two products being compared, or rather the two variables being compared. Okay, and you have a Spearman's coefficient that you can calculate based on that. So in this case, as you can see, we only have 10 products, or this could actually be your panelists, and we are comparing the chewiness and the hardness value. So in this case, you want to see if there is a correlation between chewiness and hardness, across the 10 products that were evaluated. So since the D is based on rank difference, we first have to translate these interval or ratio variables, chewiness and hardness, into ranks from lowest to highest. Okay, and then we do the rank difference thing. Okay, and because of that, we could now calculate for the the Spearman's row coefficient over here. Okay, so as you can see, itong values na ito, pinakamalaki yung coefficient niya kapag puro zero yung sagot, or meaning yung ranks ng bawat pair ay parehas. Kasi 1 minus 0 ang lalabas dyan. So although the value itself, which is between 0 and 1, could give us a good idea about how strong the relationship is, we could still use this table to check for the critical values or the significant difference at certain alpha levels, whether it's one-tailed or two-tailed. And since in this case, for example, one-tailed test, it is higher than the critical value, then it is significantly, the association is significant rather at one-tailed alpha 0.05. Take note, however, that we cannot conclude causation in this case, so we cannot say whether yung chewiness ba yung nakaka-affect sa hardness or other way around. Okay, in the previous example, although kinonvert to ordinal yung data, well, actually, depending on your assumptions, you could have assumed that it was at least a interval data. Although, sa bagay, kung yung understanding natin ng texture profile analysis, posible rin na kahit may numbers siya na continuous ay ordinal lang siya, since some of the texture parameters are actually just calculations from force measurements, no? So anyway, we can leave that to the experts to determine kung pwede nga ba talaga siyang parametric or ordinal. But either ways, it was converted to ranks then. But if you want to use, if you are sure that totoong interval or ratio yung data ninyo, then you can use the Pearson's correlation coefficient. Of course, in this case, there are identified dependent and independent variables. Okay. So nasa experimental design na yon. Alright, and similar to the previous one, if the R value you calculate is larger than the critical R value, then there could be a significant correlation between the two variables. So if you were to take the earlier example on cocoa powder and brown color, of course in this case, obviously the amount of cocoa powder added would be the independent variable, because logically the color would change based on the amount of powder added. Okay, so to make the tabulation easier, we could use columns for the individual summation terms, the x squared, the y squared, and the xy, and we could just easily sum them up to factor them into this equation. So in this case, the coefficient obtained is 0.98, and we could see as well in this case that an increase in the amount of cocoa powder added, okay, would more or less increase the brown color intensity, in which case parang eto lang yung medyo sumira dun sa trend natin, okay. tsaka ito. So, but generally, the points are somewhat in order. Ito pa pala. Okay. So, yun. So, again, in other cases, this may have been the panelist number. Okay. And these are two attributes, either a sensory attribute, physical-chemical attribute, or demographic data that you could be comparing instead. Okay. So your n is 14, and therefore your n minus 2 degrees of freedom is 12. If we're assuming a one-tailed test, an alpha of 0.05, then the critical value is 0.458, which is much lower than the correlation value of 0.98, which is obvious naman na significant yung correlation natin. Of course, and it's very close to 1, so that should have been a pretty nice hint. Okay. Again, we do not conclude causation, pero madali na siguro i-explain yun sa logic dahil sa kulay and the controlled nature of the test, kung saan wala ka namang ibang variables na uncontrolled, kundi yung amount ng cocoa powder na inad mo and the fact na established yung kanyang pagiging independent, rather yung pagiging dependent ng kulay doon sa color ng powder. At sa ulo ng mga nagbabagang balita, 3 bata natagpuang basa matapos maligo sa ulan. Okay, so gising na kayo. Right now, so regression na po tayo. Extension ito ng results ng correlation analysis. So, of course, this one is a bit more advanced. You can still use scatter diagrams. Okay. Although, especially in predictive modeling, mas marami kang ma-extract na information. And typically, yun nga, automated na rin ito sa Excel. Marami dyan, right-click mo lang, add trend line, convert data, and so on and so forth. Okay. Typically in regression, we calculate a mathematical expression of prediction and allows an accurate plot of a line in a graph or yung tinatawag nating trend line. Okay, which of course hindi naman parating line yan, no? Minsan curve siya. Okay? And malalaman mo kung aling variable yung nagpipredict kanino. Okay? So, hanggat maaari, kung kaya nung collection ng data mo na ma-regress to make predictions, instead of just associations and correlations, then you should use this one. Okay, so wag naman kayong masindak dito. Parang ano lang to actually yung slope equation while y is equal to mx plus b. So lahat naman ng lines ay ganyan ang format. Meron kang slope and meron kang intercept. Of course, the more complicated the equation pag hindi na siya linear. So pwedeng meron ka ng beta sub 2 and x squared na idadagdag na term, beta sub 3 x cubed, and so on. So yun, no? So there's a response variable and a predictor variable. So yung independent and dependent. Parang dun sa cocoa powder, right? And then it's also possible to have a multiple linear regression wherein you have more than one predictor variable for a certain response. So typically, no, sa mga totoong buhay ay ganito. For example, if your response variable is a hedonic scale rating, of course, yung product mo, marami yung ingredients. So the concentration per, let's say for each ingredient, may be a predictor variable like sumobra sa asin, bababa ang hedonic response. Sumobra sa asukal, bababa ang hedonic response. Pag walang pait, tataas ang hedonic response. So mga ganon, okay? So typically, you can do this on a spreadsheet or manually or semi-automatically by inputting summations on a spreadsheet and just typing the equation there. Or right-click kung merong automatic na function for that. Alright? So, For the general expression of y is equal to the slope plus intercept, so there is an equation for the slope and an equation for the intercept based on your x's and y's. Okay, so taking the previous set of data from the cocoa powder and brown intensity color from earlier, we could use these equations. You can try to do it manually just to see that it works, or doing this in the spreadsheet to practice yung pag-input nyo ng mga formulae. So of course, you can see here that you've manually obtained for the beta 1 or the slope and the intercept as well. So you just format that into your typical linear equation and you would get a predictive model. So ano po ang gamit nito? Ayon po sa datang ito, okay, and within the range of this data, supposedly, if you have an amount of cocoa powder added anywhere from 30 to 95%, you can predict the brown color intensity using this equation. Of course, hindi naman yan foolproof kasi nga hindi nga totally linear yung equation ng R niyan, 0.98 lang, di ba? Pero syempre, pag mas mataas yung R, mas maganda rin yung kalalabasan ng regression equation prediction strength more, something like that, no? So again, if you use this dun sa below 30% or higher than 95% cocoa, actually uncertain ka na dun kung susunod pa siya dito sa trend kasi outside na yun dun sa minodel mo, so to speak, no? So medyo mag-question ka na dun, pwedeng tumama siya, pwedeng hindi. So we could estimate variance from the mean standard error. In this case, a lower value is considered better. So in this case, to test whether we are to keep both the slope and the intercept as part of the equation, we individually test them using the following hypothesis and equations. So as we can see here, in this case, the alternative hypothesis is accepted for the slope but not for the intercept, and therefore we could more or less predict the effect of the amount of cocoa on color simply using the slope alone. So we can calculate for the r squared using this equation. So take note that y involves the actual values obtained experimentally, while y prime are the predicted values based on the said equation. Of course, an r squared that's closer to 1 is considered desirable. Alright, so there you have it for this week. So again, we have discussed three major things: association, correlation, and regression. They differ, of course, mainly on the type of data used and to the strength of correlation or association of relationship that could be established. Regression, of course, whenever possible, would be the best at as it could predict how how your data would behave. However, it would also require the most amount of data and calculation. We've just discussed the basics of regression. Of course, there are more advanced regression modeling, and typically we don't discuss how to do this manually. Same naman yung principles, but the calculations are much more complicated, and therefore mas maigi na sa software na lang ang mahalaga. Alam natin kung paano sila gamitin, saan sila gagamitin.